Hello, I am the Mad Computer Scientist. If you are new to this channel, please take a minute to hit the like button, and if you're going to hit the subscribe button, also be sure to ring that notification bell. If you find this content useful, or have any ideas for future content, please leave a comment below. On this channel, we discuss math and computer science topics, along with the occasional foray into logic. Today we're going to discuss strategies for factoring polynomials, and you know you want to know this. You've been dying to know this ever since you willingly took that algebra course, right? Alright, maybe you didn't take an algebra course willingly. The first factor for factoring polynomials that we're going to discuss is using the greatest common factor. If we are given the expression 17x squared plus 34x plus 51, we may be wondering, what are we going to do with this mess? Well, to use the greatest common factor, which is the first thing we should do when we're given any polynomial like this, is to see if there are any like terms. Now, if you've paid really astute attention, you may realize that 51 is not a prime number. In fact, you'll note that it passes the divisibility by 3 test. And you're also probably wondering, yeah, well that's true, but 17 is not a multiple of 3, and neither is 34. Well, you probably have realized that 34 is 17 times 2, and if you add 34 and 17, you do get 51. So we realize that, hey, we do have a common factor here. Even though it didn't seem so at first glance, we can factor out a 17. When we factor out the 17, we get 17 times the quantity of x squared minus 2x minus 3. Now this makes factoring a lot easier, doesn't it? I want you to see if you can try to work out this on your own. Pause the video here and we will be back later. Okay, so we have factored out the 17. What are we going to look for now? Well, this is a relatively simple case, because in the first term the coefficient is 1. That makes things a lot easier for us, doesn't it? The last term has no variable, which makes things also easy for us. And what we're going to do is we're going to look at the last term. And we're going to figure out which two factors we can combine in some way to make 2. In this case, 3 is a prime number that only has 2 factors, 1 and 3. So if we add 1 to negative 3, we get negative 2. And we're going to use that to get our final answer. So now we have 17 times the quantity of x squared minus 2x minus 3. So one thing I like to do here is actually set up 2 sets of parentheses, and we're going to figure out how we got x squared, which is just x times x. Now we're going to take a look at the c term, and we see that it is a 3, and we see that the b term is negative 2. So we're going to look at the factors of 3, which are 1 and 3, because 3 is a prime number, and we're going to figure out how we can combine those to get 2, or negative 2 in this case. And this one works out pretty nicely, because negative 2 is negative 3 plus 1. And of course, we're going to put the 1 and 3 inside the parentheses on the right side of each set, and we have our last terms. After that, we just need to add the signs, so when we combine the like terms after we multiply them out, we get what we need. And if we figured out how to do this, we realized it was negative 3, so we put a minus sign in front of the 3, and 1, and we put a positive sign in the 1. Now, I'm going to highly recommend, instead of just taking my word for it, you use what I told you in an earlier video about how to multiply polynomials together, either the box or the FOIL method, to make sure my answer is right. And if it is wrong, which I'm pretty sure it's not, but I do make mistakes, I want you to comment in the comments section. are probably asking yourself, what if we have a coefficient, even after factoring, that is not a 1? Well, that's not necessarily a problem. Let's say we have 3x squared plus 8x plus 5. We know that we can't factor out any terms because there's no greatest common factor, so we're just going to check the first and the last term and multiply them together. Wait. How did I get that? I need to go back and edit. And speaking of mistakes, while I was editing this, I just found one I made. It's not really that amusing, but it is important to note that I make mistakes too. For some reason I multiplied the a term and the b term together and got 24, when I should have multiplied the a and the c term together and gotten 15. And you'll see it's still there because I didn't correct it yet. And I'm just going to leave it in just to show you that I do make mistakes. But I'm going to say 15's factors, not 24's, are 1, 3, 5, and 15. Now 3 and 5 equals 8, so we're going to figure out how to get 8 by the factors of 3, which are 1 and 3, and the factors of 5, which are 1 and 5. We're going to set this up the way we did in the previous problem with the two sets of parentheses, and we put the x terms on the left. You don't have to, that's just convention, that's the way I like to do it. And then we're going to use the factors of 5, which are 1 and 5. So, as I stated previously, we're going to use the factors of 5, 1, and 5. Then we need to figure out how to pair them with the factors of 3, 1, and 3, so that if we multiply a polynomial, we will get 8. I have put the factors on the left side, and let's check what happens if we multiply 1 times 3x, we get 3x. And if we multiply 5 times x, we get 5x. So if we add 5x plus 3x, we get 8x, which is what we want. Now that we've put them in, we still haven't finished our problem. We need to make sure that when we multiply things out, we get the signs that are in the problem. In this case, all the signs are positive, so all we need to do is insert 2 plus signs. And we have solved this problem. Doesn't that make you feel good? The last strategy we're going to discuss is my least favorite of all the strategies discussed here. It's factoring by grouping. Let's say we have the problem 2x squared plus 9x plus 10, and we're asked to factor it by grouping. We're going to do something that's similar to what we did with reversed FOIL. We're going to find something called the master product, and we find the master product by multiplying the coefficient of the a term times the coefficient of the c term. The coefficient of the a term in this case is 2, and the coefficient of the c term is 10. So we multiply those two together and we get 20. Now, what are we going to do with those? Well, we're going to look for factors of 20 that will give us 9. Now, if you factor 20 out, you will get 1, 2, 4, 5, 10, and 20. And in this case, the factors we want for 20 add up to 4 and 5. Let's see how we get that in the next slide. So in this case, rather than trying to reverse FOIL, we are going to break down 9x to the terms 4x plus 5x and replace those terms with 9x in our original expression. The next thing we're going to do is group the terms that have common factors together. We can see that 2x squared plus 4x have a common factor of 2x, and 5x plus 10 have a common factor of 5. So we're going to factor the 2x out of the first term and get 2x times the quantity of x plus 2 added to 5 times the quantity of x plus 2. Now we can see that both terms in the parentheses are the same. If you're thinking ahead, we're probably going to guess that this might have something to do with the distributive property and that's why this works. But we don't really need to focus on that right now. we're going to remove the x times 2, put it into a single parenthesis, and then we're going to put 2x plus 5 into the parentheses, and we may have our answer. As always, I would like you to pause the video and try to work out my answer to see if I'm correct. Assuming you paused the video and didn't mind the awkward silence, I'm going to come up with some useful patterns that you'll find here. Now there are two patterns I'm skipping, largely because that's going to take a specialized video all of their own, and those are the difference and sum of cubes, which have their own factoring rules. The difference of squares is simply one square with another square, so x squared minus 16 will factor to x plus 4, x minus 4. The perfect square trinomial, x squared plus 2x plus y squared, will factor to x plus y, the quantity squared. And now we're at the end of this video. If you find this content useful, please be sure to share it out. As always, remember to like, comment, and subscribe, all those things YouTube likes. And actually, I believe I promised to do something on the whole team problem, and I will get to that next. I am sorry, I was busy with grad school. I didn't have much time to get to these tutorials. Hopefully I will get to more over the summer. Go out there and write some excellent code.